Hi, in this video, I will be showing you problem number 45 of chapter 11 section 2. Determine whether the series is convergent or divergent by expressing Sn, namely the partial sum, as a telescoping sum. If it is convergent, find its sum. Sigma, n varying from 1 through infinity, 12 over n times n plus 3 in the. So the partial sum Sn is sum to n terms of the series a1 plus a2 plus a3 and so on up to an. This can be in short written as sigma ai, I varying from 1 through n. So sum to n terms. You take only the first n terms of the series and add. So if I replace n with I here, so it's going to be sigma 1 over I times I plus 3, 12 over I times I plus 3, and I varying from 1 through n. Now let's consider 12 over I times I plus 3. We're going to apply resolving into partial fractions. So we are going to write this as a over I plus b over I plus 3 and determine what the constants a and b are. So we can write here 12 equal to a times I plus 3 plus b times I. Call it step 1 and determine the constants a and b. So if you substitute I equal to 0 in 1, we get 12 equal to a times 3, I equal to 0, I plus 3 will become 0 plus 3. bi, as I is 0, b term will cancel out. So this will give us a equal to 4. And then we will substitute I equal to negative 3. So 12 becomes a times 0 plus b times negative 3. Or negative 3b equal to 12 or b equal to negative 4. So we got a and b. So now we can write sigma or Sn, which is equal to sigma I varying from 1 to n, 12 over I times I plus 3. So I am referring to actually the step, the partial sum. So this will be equal to sigma I varying from 1 to n. From what we found out on a and b, we have written this 12 over I times I plus 3 as a over I plus b over I plus 3. So we can write this as a over I plus b over I plus 3, where we know what a and b are. So it is sigma I varying from 1 through n. So if you substitute the values of a and b, it becomes 4 over I minus 4 over I plus 3. We call it step 2. Now we are going to expand this 2 by giving values for I successively starting from 1 through n. So the partial sum becomes, so you start up with I equal to 1. So it becomes 4 over 1 minus 4 over 4. That will be the first term, which we got by substituting I equal to 1. The second term is I equal to 2, is obtained by substituting I equal to 2. So it is 4 over 2 minus 4 over 2 plus 3, which is 5. Then you plug in I equal to 3. 4 over 3 minus 4 over 3 plus 3, which is 6. So then you take one more term just in case. So 4 over 4 minus 4 over, then I'm substituting actually 4 here. So 4 plus 3, which is equal to 7. So that's how I get first 4 terms. Then I keep continuing this. Then at the end I'm going to plug in now n minus 3. So the last 3 terms are n minus 3, then I equal to n minus 3, I equal to n minus 2, I equal to n minus 1, and I equal to n. This will be the last 4 terms. As we wrote first 4 terms, it's better we write the last 4 terms as well. So let me start with I equal to n minus 3. I'm writing terms, last 4 terms. So last 4 terms will correspond to I equal to n minus 3, I equal to n minus 2, I equal to n minus 1, and I equal to n. So I'll have 4 over n minus 3 minus 4 over, so n minus 3 plus 3, so the 3 will cancel out, so it's 4 over n. So this is the term corresponding to the value I equal to n minus 3. Same way you do I equal to n minus 2 plus 3, that will be n plus 1. Then it is 4 over n minus 1 minus 4 over n minus 1 plus 3, that will be n plus 2. Then 4 over n minus 4 over n plus 3. So in this step 3, we have written first 4 terms of the partial sum and also first 4 terms of this Sn partial sum, then the last 4 terms. Here we notice we are going to have a lot more terms in the middle, but we can get an idea of what the value is going to be at the end. So if you notice here we have a negative 4 over 4. So we notice that 4 over 4 and a negative 4 over 4 will get cancelled out. So we will have ultimately the terms, first 3 terms, the first terms of the first 3 terms will remain, which is 4 and 4 over 2 and 4 over 3. Same way we will have these 3 remaining in the last 3 terms. That is 4 over negative 4 over n plus 1 minus 4 over n plus 2 minus 4 over n plus 3 because of its telescoping nature. But anyway, we are going to do n is approaching infinity for this Sn. So when you consider Sn, the partial sum, and then you allow n to approach infinity, so limit as n approaching infinity of Sn would be the first 3 terms only, because the other terms are going to approach 0. 4 over n plus 1 approaches 0, 4 over n plus 2 approaches 0, 4 over n plus 3 approaches 0 as n approaching infinity. So this becomes just 4 plus 4 over 2, which is 2, plus 4 over 5. When you simplify that, that will be 22 over 3. Because the partial sum converges to a definite limit, which is a number 22 over 3. The series converges and it converges to 22 over 3. So the given series, sigma n varying from 1 through infinity, 12 over n times n plus 3, converges, and it converges to 22 over 3. Hope this video helped.